Hello, and welcome to today's session about data science and use cases for businesses. First of all, let me introduce myself. I am Ayman Al-Quraini. I am a principal consultant and data scientist working at Next Era Technologies. I have more than 12 years of experience in cross-functional roles that includes engineering, planning, business analytics, and consultation services. I'm a technology enthusiast with interest in disruptive technologies that include Internet of Things, smart city solutions, data science, machine learning, artificial intelligence, big data and analytics, and many more. I studied the Master in Data Science and Analytics from University of USM. Before that, I had my MBA in Technology Management from University of Canberra, and my bachelor degree was in electrical engineering with focus on computer at Skillset University. In today's session, we will be covering the following key points and answering some questions. Those falling around the definition of data science, trying to differentiate between machine learning and artificial intelligence, and how those terms used in the context of data science. We will tap on the domains that using data science in their applications, why data science is important for their business, and what are the use cases that being implemented in those industries and those businesses. After that, we will talk about the skill sets that need to be that the data scientist should have in order to be successful in his job. And at the end, we will talk about our training program, which is the data science certification program, and how it helps the professionals who want to enter into this field to gain all the skill sets needed to help them be successful in this job. We will have Q&A session at the end of our presentation. So we live in an age of data, and data is generated around us from all sources, and has been highlighted in World Economic Forum report in 2013. They highlighted that data is the new oil. Data is just like the crude oil. It's valuable, but if it's unrefined, it cannot really be used. It has to be changed into gas, plastic, chemicals, and so on, which creates value entity that drives profitable activities. And the same way is the data. It needs to be broken down, analyzed, so that we can have value from those data. As we said, an increasing amount of data are generated every year. A need to analyze and create value from this asset is more important than ever. And the companies that know what to do with their data and how to do it very well will have a competitive advantage over their competitors who don't know how to handle this data. This creates a huge demand for people who possess both the analytical and technical abilities to extract valuable insights from those data. Putting these insights to action needs someone with a business acumen to create valuable and pragmatic solutions where data scientists came into the picture. So in simple, as huge data around us being generated, we need to analyze this data. And to analyze this data, we need people who have the right skills to analyze this data and come with the insight from this. But also coming with the insight will not be helpful for the businesses if it's not answering the business needs. So we need someone who has business insights, who knows his business, and at the same time he has the technical skills to analyze the data, extract the knowledge from this data, and build a solution that helps the businesses. So that's why the term of data scientist is very unique. It's an interdisciplinary role. It's not technical, it's not business, it's something between them all. And as we'll see later, we'll just tap on all the skills that need to be, the data scientist should have and gain in order to do his job properly. First of all, let's define now the data science, what data science is. And this is one of the best definition available there. which says that data science is the science which uses computer science, statistics, machine learning, visualization, and human-computer interaction to collect, clean, integrate, analyze, visualize, and interact with data to create data products. If you see this definition, it has the process that the data, goes through the data science project in order to convert it from, starting from collecting this data and end with interaction with this data to create a data product. And if you see, I highlighted here as well the important terms. Machine learning, we'll come later and see what's machine learning. Data product, we want to see what's really data product, and the process that the data go through in order to get insight from this raw data. Again, we have the data, we want to convert it to data product, useful, has business meaningful data product, and this can be done mainly by applying machine learning algorithms. We will see this in detail. So as we said, data science is an interdisciplinary field that came as a result of convergence of technologies and studies in many domains. Data science is the area of scientific studies for extracting knowledge from large volume of data. It's quite often very difficult to understand data in raw form. So the data in raw form, it will be numbers, it will be pictures, it will be video files, and we want to extract meaningful knowledge from this data. It cannot be understood immediately, so we need to work on this one to create the insight. So it's very important to interpret key ideas of large volume from for various reasons. So in the previous slide, we say that this science is in fact the science which is changing the data into data products. So let's see some examples of this data, raw data, and how it's being converted into products. And here we have few examples. If we say that a transaction database, which is banking financial transaction database, we can use this data to convert to fraud detection product. Most of us, if they have used their credit card abroad, if their bank is registered in Saudi Arabia or Emirates or any other country, and they went traveling abroad, and they try to buy a souvenir, and this souvenir they don't use. Normally they don't buy it. The system will detect that it seems there's a fraud. Someone trying to use the credit card to buy some product, which is the user normally don't buy it, and from a location that he is not there frequently. So it will alert the system in the bank, and the bank might freeze your credit card. It's for protecting you from being a victim of a fraud, but at the same time, maybe it will cause hazard. So fine-tune the product, fraud detection product, to improve its accuracy is very important. Let's take another example. So wireless sensor. We have sensors everywhere now. It's like you have the cameras, CCTV cameras. You have the sensor that detect if the doors are open. There is the image recognition and so on. So you can use all those sensor data and convert it to smart home application or smart office application. Let's say for example, if you have software log data. This software log data is the raw data that you collected from your software operation and application and the usage of this software. You can convert it into a product which is do automated troubleshooting for this specific application. So this is just some examples about how to turn the data, the raw data, into application. And till now, it sounds good. We see that we are trying to get some insight from the data. But who are really the data scientists? Who plays its role? And it's part of, we would see, is it part of computer science? Or is it a business role? It's a research role? And this diagram represents the percentage of people who are working as data scientists compared with relevant to their educational background. And we can see it's very clear that it's not falling into any category. So people who's working as data scientists, mainly coming from any field. Most of them coming from mathematical and statistical. Some of them come from engineering, some from computer science, some from natural sciences, social sciences, economics, business. So you have like people from any field who can be data scientists, because the data is everywhere now. And you are at your field, you want to get insight from this data. And the best one to apply the concepts and the algorithms of data science and to his business is the one who knows he has the business insight of his field. So yeah, I mean, this is answering. I mean, there is a big debate about, I mean, who should be data scientist. Most of people talking about that is computer science is the data scientist, but this just makes it clear that it is not right. So we can talk about data science without coming across artificial intelligence. In general, it's the ability for a machine to perform tasks that would normally require a person to do. So artificial intelligence is trying to mimic the human brain, trying to solve problems using human brain mechanism. So it's just like people. It's the ability to take information, making decisions based on it, and cause an action. So we have the information, the input, data, sensors, images, do artificial intelligence, and take actions out from that one, which will help us in solving a specific problem. So,
inputs, which is data, sensors, the images, and converting this, do some artificial intelligence over that one, and come outcomes of this as action of movement or text. So in simple artificial intelligence, we are looking at as boxes here. We take input as data or sensors or images as the input. We do some algorithms over that one and programming and so on, and we'll get actions, results, and so on. We will see that the artificial intelligence is divided into different subdomains. And as a subdomain of artificial intelligence is the machine learning. And a subset of machine learning is something called deep learning. And deep learning, in fact, it is the state of the art or what's going on currently in the world. They are focusing on machine learning and deep learning to create all the automation and all the artificial intelligence application. So let's come back and talk about the machine learning itself, how it works. So first off, we have the machine, and which is computer, can be computer, can be only a software, and we have we want to create insight from the data or solve a problem. So in the past, this has been done by programming individual skill manually. For example, I know that I have a problem, and to solve this problem, I need to do 1, 2, 3, 4 steps. So I program it manually, and the software do it for me. But what we are looking for now, and what will be implemented, in fact, is to try to mimic the human brain. Try to find a way that the human brain is working and create similar software or that do the brain job. So if we come back and try to explain the machine learning, it is so we have like training. If we want to solve a problem, we will try to capture as much as information that we get about this problem. We split our data into training data and testing data. We try to build a model or algorithm which is solving this specific case. And once we are happy with the results of that training, over that training data, we put it into production. It's very high level here. We will come to it later. But the question is here. I mean, we are talking about automating the process. automating the process of solving the problems and try to make it more like a human doing it. But is it something new? And the answer is no. And we can see from this picture, like back in 1770, 18th century, there is a Hungarian inventor who created a machine that can play chess against a human. And in fact, they call it the mechanical Turk, because of that time they still have the feeling that the Turks are very advanced in their technologies and so on and so forth. So they just invented a machine, which is in fact is not a real machine. There is, as you can see inside this machine, there is a human who's playing the chess, but they try to make illusion and they try to make some shows in their theaters to get some more audience. So from here, people start to think of automating the process and doing the job by virtual machines. And this being done successfully or implemented successfully in our 20th century. If you remember in 1997, when Deep Blue supercomputer beat Garry Kasparov in the chess. Garry Kasparov were the world champion of chess, and that's the first time when computer beat the human mind in using artificial intelligence. So we are hearing a lot of talk about artificial intelligence, its application, what can be done by using artificial intelligence, and the big question is it real? Is it available there, or is just we are imagining it? And this diagram here illustrates the status of artificial intelligence application in our life today. In fact, this is not today. This diagram being created in December 2016. It's like 1 year back, but still it's valid because we are talking about 1 year and we can just see the difference. If you can see here in the, let me just put the laser. If you can see here, the dark blue is what's available now. The lighter blue is something will be in 1 or 2 years, so we should be seeing it now. And the sky blue is something we will see it in 2 to 4 years. Let's go through with it one by one here. So we have autonomous system like SUV, طيارات بدون طيارة على سبيل المثال. عندك machine learning, we have the deep learning, we have the neural networks, we have the pattern recognition, we have the natural language processing, and we have the chatbots. All those applications are currently in a product. It's commercial products. It's been used in market, and you can just buy it and use it. If we come here, this is still a lot of application being here and need to be done here, like real-time emotion analysis. When we talk about real-time emotion analysis, we heard if there is a solution available now which can, in real time, analyze any video stream, and they try to come up with the emotional status of the person on that video. Is he sad? Is he happy? Is he suffering from any sort of pressure? Is he lying? Percentage of lie in his talk, and so on and so forth. This is real application. This is application which is available now, and so on and so forth. So we can just see artificial intelligence. It's a huge domain. A lot of work being done here. A lot of achievement done already, but we still have a long way to go through it. We at the end of the day, we don't want to talk about the let's call it the higher end of the artificial intelligence applications. SUVs, UAVs, طيارات بدون طيار, سيارات القيادة الذاتية, and so on. It's the same principle. You can use the same principle and same techniques to do whatever you want in those fields. But we want to focus on our discussion about business applications. And as you can see in this image, you can apply the data science and the data analytics at any industry. You can just pick any industry and you will have application for that one. We will just choose a few applications in some of the industries to illustrate how we can benefit from the analytics. But what data scientists can do and how they can add value to the businesses. They can add value to business in 8 ways. First, they can empowering the management and officers to make better decisions. As we said, we are backing the management decision by data. So it's called data-driven decisions. Data scientists direct the action based on the trends, which is in turn help in defining goals. It's analyzing the data, finding any trends in the past, and they try to make future prediction about what we need to do to improve our sales, to reduce our churn, to improve the quality, and so on and so forth. Data scientists challenge the staff to adopt the best practices and focus on the issues that matters. Instead, we know in operational management and resource and human resource planning and human resource HR departments, our biggest challenge is just to improve the productivity of the people. And using analytics and using data science, it can help the management to define the process flow. They can help them to define what needs to be done first instead of just doing it in sequence, just to be paralleling the jobs. This insights can be taken out from the data and the history of the jobs being done before. We can identify opportunities, decision making with quantable data-driven evidence, testing these decisions, identifying and refining of target audience, and recruiting the right talented for the organization. This is the 8th way that data science can add value to any business. But we want to see applications. We are talking from the beginning about the data science, the machine learning, artificial intelligence, what can be done, but we want to see a real application. And let's see in our next slide. This is some of the applications where we can apply machine learning in, where data science can take a good effect. This is application which is really available in the market now. If we take manufacturing, for example, the first quarter to the top left, we see that predictive maintenance or condemning monitoring. The biggest challenge for any manufacturing line is the maintenance, predictive maintenance. If we want to make a maintenance for that line, we normally shut down that line, which is halt all the operation. We make the maintenance and then we run it again. And if it's time-sensitive industry, for example, if it's oil and gas industry, then every hour is millions of dollars. If you just shut down one plant for 1 hour, it's millions of dollars that you lost due to the halt of the production. So you can use the data which is coming from that production line, from the sensors that apply in that production line, and try to analyze it and analyze the fault history, and you can identify what caused the problem and when it will be happened. So instead of just doing a preventive maintenance, as we know, normally in any industry we do preventive maintenance. Okay, every 6 months, for example, we go and try to check everything to make sure that it is fine. But do you really need to do that predictive maintenance? Do you need to do it every 6 months, or 1 year, or 2 years maybe? Or maybe I need to do it very frequent in 1 or 2 months. Who defines how frequent I should do my preventive maintenance? It is trying to find out the insight from the history of the incidents and what caused it. And this is not any preventive maintenance anymore. It's a predictive maintenance. I know when the fault is going to happen and at which part, so I have the spare parts ready, I have my technician ready, so I minimize the downtime. Warranty reservation estimation, bench to buy, demand forecasting, process optimization, telematics, all those are applications that you can apply to manufacturing. Let's go to retail, for example. Because predicting inventory and inventory planning, and instead of just having inventory for all the products, at each and every retail store. Some areas the people consuming specific products more than other places. And so you need to do your analytic system that help you to identify what are the products that are purchased in this geographical area by those customers and in which time frame. So you plan your inventory in a best way. Recommendation engine. All of us, when we try to buy something online, you will get recommendation. For example, if you go to Amazon.com, Souk.com, or any online store, and if you buy one product, you will find a list of other products which is recommended for you by the website, saying people who buying this product normally buy that, or maybe based on your search. We all faced the case when we were searching for something online on Google. Then all the advertising coming on Facebook, LinkedIn, Instagram, on social media in general is advertisement for this specific term that we search on. So this is the recommendation engine. We call it recommendation engines. Or for example, someone who buy a product. Let's talk about the telecom industry, for example. You are an STC or Mobile or Zain customer, and you are in one package or so. It's a prepaid package. 100 riyal per month, for example. It's good, but the company, they want to know, are you willing to pay more or less, or you are happy with this package? And if you want to buy it to pay more, which services you are willing to pay? Okay, you want to buy data, for example, or you don't want to buy data. You want to go for a lower package. Why they care about this one? Because if you are not happy with the company what's offering to you, you will look for a competitor. You will switch from SSC to Zen, for example, or from SSC to Mobile. So it's the company who need to take actions and to measure when you are potential customer to churn or to move from this operator to another. So they take preventive action and try to increase your satisfaction, so you're maintained with them. Or to do upselling. I mean, they want to increase their ARPU, average revenue per month, from you. Marketing segmentation or customer ROI and lifetime value. All these are applications being done in retail. Let's go down. Let's try to talk about the financial services. So as risk analysis, we tap on one of the applications in financial services, which is the fraud detection before. Like credit card fraud detection. But there is also the loan. If you want to take a loan from any bank, they want to make sure that you are a good customer who is going to pay them back or not. And we all, when we apply to credit card or to a loan, to car loan or whatever financing from a bank, they take our information. They ask for so many questions, and then they will do their analysis. And they come with the result. Either he is a good customer or not good customer. What's the probability that he's going to pay back his loan or not? And based on that, they decide how much loan they will give you and what are the percentage over that loan, all as part of the risk calculation. If we take the last one, which is the energy and utilities, so analyzing the power usage, this will help the utility company to direct enough power to a specific area during a specific time, because we have times when the customers using they have high demand for power. For example, midday, it's the peak hour for them. Midday and so on. In our countries, for example, when we have different temperature during the year. We have summer, winter, and so on and so forth. Then the power consumption is somewhat different than in winter, and so on and so forth. So you need to do a proper planning for your power distribution. Seismic data in oil and gas. Let's take oil production. What they are doing? They are going to middle of nowhere in the desert, and they are trying to collect a huge amount of data, the seismic data, and normally they send it back to the office to process this data and do some analytics and try to come up with the result. Is it a good location? Are we going to get oil from digging in this place or not? But with the advancement of edge computing and on-the-fly real-time data analytics, I mean, the engineer on site, he can just define. There is no need to do a lot of job. I mean, he's just collecting the data, and on the flight, there will be analytics being done on that one, and give him the result. Do I do it this way, or I need to move maybe 2 kilometers to the north and get a better result? And so on, smart grid management. We all talk here about smart grid, or smart metering, for example. So those are a lot of applications which have been done into so many fields. One good example as well in the aircraft industry, in the travel and hospitality. We know that the failure of an engine during a flight is a disaster. You have hundreds of people over a flight, and if the engine is failed over the flight, then you lost hundreds of lives. So having a predictive analytics over the aircraft engine, and knowing what's the lifetime for this engine, when it's going to fail, going to save people lives and decrease the predictive maintenance that's been done on that engine, and it will be win for everybody. As we see from this, I mean, we can take any vertical or any industry, and we will find applications for that industry using data science. But it's not only industries and verticals, even its functional areas. I mean, in any company, as a sales department, you care about churn, which is the customer that leave your company and going to your competitors, who are switching to their competitors. So you want to understand when those customers are potential customers to churn, to be part of the churn. So you take preventive action with them, or you want to improve your selling through cross or upselling, or the marketing. You are making a marketing. We see a lot of marketing being done by companies, but what are the ROI on that one? What are the return on the investment in this marketing? So you need an analytics part on the marketing strategy. You have marketing strategy, and you need to do analytics over that strategy to understand is it paying back or not. So those some of the examples where we have applications for data science. So again, as you remember, we discussed that data scientists came from different backgrounds and working in almost every industry and functional roles. But what skills those data scientists need to possess in order to be a successful data scientist? And we will look in the next slide, on the skill sets for the data scientist or successful data scientist. And as we said, I mean, successful data scientists need to master skills that starts with software skills like communication, telling stories, and end up with technical skills like data wrangling or data manipulating. And in between them, they have to master machine learning concepts, algorithms, and techniques, and how to visually analyze the data and getting insight from this one. So data scientist role, it's a big role that's it's a big role that needs to master too many skills to be successful in what he's doing. And that's why normally data scientist is reporting to the higher management. They are not part of the IT department. They are not part of the sales department or marketing department. They are normally working directly with the decision makers, either CEOs or MDs, because they are helping them in taking their strategy or building their strategy and backing it up with the data and the prediction about the future company future and where to focus on. So this are the skills that any professional need to get in order to be a successful data scientist. I mean, those are high level, but if you just dig in deep into any of them, you will find a lot of things. For example, mathematical and statistical, you will find here the machine learning algorithms to be applied here. If you go to computer science, you will find that you need to do a small, short coding. If you go to the business domain, you need to extract your knowledge in this domain and what's really affecting and their revenue and their customer satisfaction. So if we take business domain and analytics, you will have advanced analytics rule. Or if you want to be a computer science and you have good mathematics, you do machine learning engineers, for example. But if you possess all the skills here, you will be what we call the data scientist. And this is where It's like the top selling, top paying rules currently globally. So this was the introduction about data science and its applications and use cases in different industries. And I started this just to give a brief about it and just to open the eyes about what skills need to be possessed by people who want to enter here. Because anyone at any field or from any background can be data scientist. He need to get the right skills that help him in doing his job, then he is a data scientist and he can just apply for that job. So what we are doing here at Next Era Technologies is to help professionals who want to enter this domain. We built our training program, which is helping professionals to enter into this domain. So as we saw, how data scientists need what skills to master in order to land a dream job in their field. To help those professionals breaking into this field, we designed a series of training tracks that help individuals entering this domain as quick as possible. Our training is a practical, hands-on training that work with you hand in hand to master the skills you need in relatively short time. So it's not theoretical training; it's a practical training. It's hands-on training, which works with you hand in hand to master all the skills in short time. As we said, since this data scientist is being defined as a 6 years job in the 21st century, so many people are turning into it, and so many people are trying to acquire all the skills needed to be a data scientist. So as a quick, you can join this phenomenon as much as you can gain from in terms of salaries and benefits. So So as we saw that data science is an interdisciplinary role, therefore we designed our training program to cover all these disciplines. We are covering the computer skills that needed to be possessed by the data scientist, the business, help them and define the business skills that need to work on, and the statistical skills. So we try to cover all the discipline that data scientists need to know it in our training. And if we look here about our training, it consists of different tracks that help you to achieve the data science professional certificate. So it starts as, again, it's a practical, fast-paced training to get you into data science as soon as possible, an immediate effect. Prepare you to explore businesses, analyze data, develop prediction models, and monitoring outputs. And we have, in fact, 3 tracks. I divided here to 4 because I want to differentiate between data analyzing and data visualization. But it's mainly big data management and analytics, where here we focus on ETL, data wrangling, collecting the data from different sources, and how to manage those data. Then we have the data analytics, where you try to build predictive models after cleaning the data, filling the missing data, and so on. And then do visualization for this data using all the visualization tools like Tableau, Power BI, Click, and so on and so forth. And at the end, here we focus on applying those for decisions. This track mainly focus on applications for real life problems and trying to solving it. So if you see, we have the 3 tracks. If you cover all this track, then you have all the skills needed to be a data scientist. And here why we divide it into 3. Some people, they say, okay, I'm good in big data, but I need more into data visualization and machine learning. So they can choose what exactly they want, and they just continue from there. After that, we will have examination, and who passes will be certified as a data scientist. Our training is not online, so our training will be in a classroom where we'll be face-to-face helping them and having the hands-on application. We will have Lego projects. We will provide a real-world cases and data sets that we use in building our models. Some instructors will be there who will help them in terms of theoretical and academical part, which covers the theories behind the machine learning, and the practical who is implementing this one in real life. We will share the material, all the topics, material, presentation, case studies, and codes we use in the training will be shared with the trainees. And the support after that, we will provide support for who participate in this training in applying those skills in their workplace, and they will be certified. In Saudi Arabia, in Q1, our Q1 calendar, we will have 3 series of training sessions. One in Riyadh, one in Jeddah, one in the Eastern Province, in Al-Khobar. We divide it by tracks, so we have big data track, we have data analytics and tracks, and machine learning track, and everyone has its planned schedule. So in Al-Khobar, for example, we will start by 6th of February, and it will end in 14th of February. Every track is 3 days, and it's 9 days. The classes will going to be evening classes, so most of the employees prefer this one because they don't want to take days off. Some companies will not provide them with days off for training. So to overcome this, we'll do it evening classes from 6 p.m. to 10 p.m. The course fees for one track is 1,800 ringgit, and the 3 tracks for getting the complete series and being certified as a data scientist is 4,500 Saudi riyals. So to register for the training, they can be registered either going to our website or contacting us on training@nexteratics.com or WhatsApping us or calling us in any of those emails. Our training partners, as we said, there's so many tools and skills that need to be mastered. So we will be helping the trainee in mastering the Hadoop for big data management and analytics. We'll talk about Sparks over Hadoop. We'll be using Tableau and Power BI for data visualization. We'll use R programming and Python as programming languages and helping in writing the scripts for machine learning. And we will use a cloud application for where we can apply machine learning and predictive analytics models on Amazon Web Services or Azure from Microsoft. So this was our session today, and I hope that you get a better understanding of what we are doing here. And if you have any question, please let me know.